So, welcome back. I'm gonna make a few sections of things that we find to be broken because I'm very curious of why something has failed, or maybe how does it look like on the inside. So the best thing to learn is actually having a look. So let's start with the first one, and you will see where I'm going with this and what I'm trying to do. We have here a small version of an oil filter. What you tend to find on big systems with more than one compressor, let's just call it a pack, or different places they call it a rack, where you have 4, 5, 6, 10 compressors, you will also find an oil separator, which also can be an oil receiver. They are two in one, or you'll find them separate, an oil separator and an oil receiver. But when you're trying to separate the oil from the refrigerant, you need to have a filter because you want to catch all the debris that is inside. So here we have a small version of an oil filter, and we can see how it looks like. So I'm just gonna bring this closer, and that's quite cool. I do like it. Got some tiny holes. So it's basically a mesh inside, or something like that. You can see a hole, and on the inside, I hope I can see. Yeah. So I think this is a better focus now, where we can see how dirty it is. So this one will sit like that. You see the tiny hole? That's where we've got the nuts. The oil with gas from the discharge coming out from the compressors, it will go through this hole. Yep. And it will be filtered through this mesh. And that's what it is. This is an oil filter. So the job of the oil separator, the clue is in the name, is to separate the oil from the refrigerant. And then once you've got that oil, you want to store it somewhere into cylinder, an oil receiver, and have it ready for when there is demand on the compressors, i.e. the track oil. When this wants oil, it will open the valve, and the oil will travel from my oil receiver into my track oil. But you need to have a filter. Now you might ask yourself, why is the filter blocked? Well, there are many reasons. But it could be compressor burnouts. It could be poor practices in service. It could be high discharge temperatures, which diminishes the quality of oil. It could be an old system and you get carbon inside. You just get debris from the mechanical parts of the compressors. So imagine you have compressors that have been running for 20 years, 15 years. So there are multiple reasons for it. So parts of maintenance, every couple of years, it depends on what the standards are. You need to change the oil filter. Because if you don't change it, this is what will happen. So how did I manage to find this was the problem? Well, simple. I came to a job. I saw the oil receiver being low on oil, and I had compressors stripping on oil because my track's oil was opening the valve to feed the compressor with oil, and I had nothing. That caused an alarm, just like this. And I thought that's a bit odd. I did put a bit of oil to the system, and then 2-3 weeks later, I had exactly the same problem. So that's when I realized there's a problem with my oil filter. So I went back to site, pumped down the system, and this is what we found. We changed it. We used an oil acid test kit just to make sure the oil was an acid. That turned out to be all right. And as soon as I changed this, my oil returned to the oil receiver. Now there is a danger if engineers keep going back and topping up the oil receiver with oil, eventually that will create other problems. So if you put 2 or 3 liters of oil, or depending on the type of system, you can put 5 or you can put 1 liter, you should start there. And then if the problem comes back again, then do not top the system with oil anymore, because this could be a problem.